Hello, everyone, and welcome to today's online MyGuru GRE and GMAT information session focusing on quadratics. It is now 9:30 Central Time in the United States, and I'm sure several different time zones where our participants are. So I'm going to give everyone a moment to log into the session, and we'll get started probably closer to 9:35 Central or 9:40 Central. So we'll just pause the recording now and be back in a moment. All right, it is now 9:35 here, U.S. Central Time. So we'll go ahead and begin our session. Obviously, this entire session will be for continuous viewing, and we'll send out links to the recording here later this week. So you'll get that as well if you end up joining a little bit late. The recording will be made available later this week for those who join late. So out here, relating quadratics. So as it stands, so discussion of just kind of quadratics as an overview. So quadratics defined. And we're going to limit it to GMAT and GRE quadratics because there's not a whole lot that you really need to master necessarily for GRE and GMAT quadratics. They're very basic. So you should assume that they either can be addressed by factoring or what here in the US is known as foiling, which is really just an acronym to solve. And what that means is that the quadratic equation should not be necessary because it's too time consuming. We will talk about the quadratic equation here in a moment just to discuss how it can help inform an approach very high level. But basically, you want to assume that I'm not going to need either the not going to need the quadratic equation. I should be able to factor or FOIL to solve these things. So let's just take a sample quadratic equation, for instance. Let's just say, let's take x. Seems a little bit too fat for me this morning. Let's go there. Yep. So let's just take a sample quadratic of x plus 7 times x minus 8. So how could we distribute or FOIL this quadratic? So what the first step would be in distributing the quadratic? And you can put it into the chat box here. X times x, which is going to produce x squared, of course. Then what's the second? We got x. And so we're going to have the outside, which is going to give us minus 8x. That is correct. And then what if we, what's the third step going to be? It's going to be plus 7x. And the final step for the constant, yes, 8 times 7 is 56. And then what's the actual final step of the process? What is the last thing we need to do? So, yep, we're going to combine what terms? it's going to come down to just the minus 8x plus the 7x. So distribute and combine like terms. And that's going to get us x squared minus x minus 56, which is the exact same as x plus 7 times x minus 8. So then let's consider the opposite, basically. Well, let me first ask, are there any questions about the distribution? I'll give everyone a second. Are there any questions about quadratic distribution? It's just making sure that all of the multiplication is processed correctly. And that FOIL stands for first, outside, inside, last, which is what we did from a multiplication standpoint. Again, if you're not a US viewer, you probably don't need the FOIL. You just understand it as quadratic distribution. But it seems like everybody is okay with this piece. So then let's consider quadratic factoring. So over here, we'll just talk about our steps for quadratic factoring. GRE and GMAT quadratic factoring. So let's consider a sample problem here. So let's go ahead. We'll just have in parentheses, or sorry, in the quadratic expansion, we've got x squared plus 3x minus 10. And we know that every quadratic has to be set equal to 0 in order to solve. So that's actually our first step. So in turn, we'll be using this as our example. So step 1 is ensure the quadratic is set equal to 0 to solve, because if it's not set equal to 0, you can't solve it. Then you want to create binomial parentheses with the first term inserted. So because the first term here should be the easiest thing to identify. So if we're looking at squared plus 3x minus 10, we've got to have these parentheses created. So what will be the first term for each binomial? And again, you can either reply in the chat box, or you can actually open up the microphone if you'd like to respond that way as well. But if we know that it's got to be x, right? Because there has to be an x to create x squared at the front of each of these binomial pairs. We're going to have an x and we're going to have an x. And this is generally going to be the easiest part. If we had 2x squared, we know that we'd have 2x and then 1x. This is the easiest thing to do every time. So then third is going to be to consider the required operations in the parentheses or in the binomials. So in this case, and you can use the constant, and using the constant by determining if it is less than 0 or greater than 0. So our constant here is going to be negative. So if we have a negative constant, what must our operations be in the binomials to produce a negative constant? So if I want to create a negative 10, what do our operations in the binomials have to be? We know we still have x, and then got to have a plus and a minus, right? Because if we don't have a plus and a minus, we're not going to be able to get to a negative 10. So now we've got plus and minus. We know that that's going to be the case. And then step 4 is to consider the factors of the constant to determine which will add or which will sum correctly to the coefficient of the middle term, basically. So largest term is the x squared, the middle term is the 3x, the single x, and then the constant is just 10. So we need to consider what would be the factors of -10 that will sum to +3. +5 and -2. Indeed. So that means that we're looking at x plus 5 times x minus 2 is equal to 0. Now, always be careful and remember that the solutions, also known as the roots of the equation, are the values of x that produce a quantity of 0, right? So in this case, our roots, what are our roots or solutions? The solutions for this quadratic. Yes, -5 and +2, because we can't forget that step, basically. So we know that the solutions are x is equal to -5 or +2. So straightforward stuff here for, honestly, both GRE and GMAT quadratic factoring. Any questions about the factoring approach here before we start taking a look at the actual kinds of questions that you'll see on the exam that can engage these sorts of these concepts? So let's go over and do sample problem, a practice GRE. Copy. And let's just consider this little problem here. There we go. And so I'll just make that bigger, and that's big enough. So the thing to recognize about a problem such as this, looks quadratic, right? And so one of the things that we just kind of have to recognize about the GRE and the GMAT is that often tough quadratics are time wasters. And instead, what you want to think about is how to solve it, like actually from a logical perspective, as opposed to trying to solve it in reality. Now, we've got to remember that that formula that I mentioned, the quadratic formula, I don't really want to use it here. And if I'm trying to factor this, factoring this is ridiculously difficult. Is impossible without the quadratic equation. Because I can't set it equal to 0, and it's just going to be hugely annoying to do anything with this from a technical algebraic standpoint. So instead, I just want to plug in easy values to make this simpler. What would be an easy value? So, well, let me ask this first. Which of the two variables in the problem should we plug in for? Yeah, I'm going to plug in for the x first, right? So if I plug in for x here, x equals, say, what? What would be a good value for x? So what would be a good value for x? Make the math easy. Yeah, if x equals 0, well, then we know that y is just equal to -3. So if x equals 0, y is equal to -3. And right now, I know that quantity A is greater. So if we're considering our answer choices of A, B, C, D for a quadratic or a quantitative comparison here on the GRE, and we know that our options are that A means A is greater, B means B is greater, C means they are equal. And those are all things that are always the case. And then we've got a little not always for our D. We know that right now, quantity B is possibly less than quantity A, so that's not a possible answer choice. These two quantities are not equal, so that's out as well. Now, if we wanted to just change up the outcome, well, I could say, well, what if x is equal to 1? And if x is equal to 1, then y is going to be equal to 2 times 1 squared, which is 4. Plus, let me go ahead and make sure everybody's muted here. And so we've got 4 plus and then 7 times 1, which is going to be 7 minus 3. We compute all that and we get that y, quantity B, variable y is now 8. And this time, obviously, quantity B is greater, so we can eliminate choice A and select choice D. And you can see plugging in is so much faster than trying to actually use the quadratic equation. Do not waste your time trying to figure out the quadratic equation here. No need to. Now, there are instances where we want to be savvy in how we address the quadratic equation. So let me go over here and hit this guy. Because the equation, very rarely are they actually on either of these exams going to just give you a quadratic equation to factor and say, have at it. It's more usually a heavy way that they will introduce the quadratic equation. So if we look at a problem such as this. So we've got this problem. And one of the things we always want to do with just GRE GMAT problems in general is skip to the end and identify the sought value and basically label your choices as that value as algebraically as possible. So what are we being asked for if we skip to the end of this problem? Well, we're being asked for the perimeter of the photograph in inches. So what is the formula for perimeter of a rectangle? So can anybody tell me, just in the abstract, what is the formula for the perimeter? Yep, 2L plus 2W. So we just come over here. We're going to just write that over top our choices here. We're looking for what 2L plus 2W is. So we don't want to try to solve for these variables individually. It's just not going to be useful at all. So you'll see we don't even necessarily have to draw the figure here. We're just going to think about it and work from the formulas ideally. So rectangular photograph is surrounded by a border that is 1 inch wide on each side. So we know that the photo dimensions, as we've already defined them, are going to be L, which is equal to the length, and W, which is equal to the width. So then we're told that the total area of the photograph and the border that is 1 inch wide on each side is m square inches. So what would be the area formula for the photo with the border? So what is the area formula of the photo with the border using our dimensions of L and W for the photograph? So can anybody tell me and that is correct. We've got L plus 2 times W plus 2. And that L plus 2 times W plus 2 is equal to what, according to the problem? M, yes. So that we've got L plus 2 times W plus 2 is equal to M. Now, then we know that if the border had been 2 inches wide on each side, the total area would have been M plus 52. So we know we're going to ultimately end up with an M plus 52 as the second equation. So what is the equation that would produce M plus 52 had the border been 2 inches wide on each side? And it is correct. It's going to be L plus 4 times W plus 4. Now, thinking back to what we've already discussed regarding quadratics, what's the next step to try to get L plus 2W? So what is going to be the next, what step is next to attempt to 2L plus 2W, which is the value we seek? So this is where we need to think about how we produce those quadratic expansion terms. So what I'm going to do is I'm going to actually expand each of these. So we're going to just take this first one, and if we expand that first quadratic, what is L plus 2 W plus 2 expanded or distributed? So what would be the first term? And we've already got the whole thing. It's going to be LW, because that's our first term, plus 2L plus 2W. Oh, there's that thing we were looking for. Plus 4 is equal to M. Now, we also have to expand out the first part, which is going to be equally LW plus 4L plus 4W plus 16, which is still equal to M plus 52. So now, is there a way to manipulate the system of equations to solve for 2L? And yep, so we subtract the equations as has been suggested, because if we subtract, and remember you have to apply the distribution all the way through of that subtraction, we know that LWs are going to cancel out. 4L minus 2L becomes just 2L. 4W plus 2W becomes just 2W. minus 4, of course, is 12. And the m's cancel out, and that's equal to 52. Then I can subtract the 12, and we get to a situation where 2L plus 2W is equal to 40. And this is very much, whether you're looking at the GRE or the GMAT, the manner in which you will see quadratics tested. It's logical. The technical math is probably not the thing that's difficult here. It's identifying what you have to do in the problem to start. So any questions about this example before we talk about some common quadratic identities and how those can show up as well in some of these problems? Any questions about this example? So then let's take a look next. So this is an example from the GMAT again. This one's pretty straightforward, so we'll just grab this over here. Actually, I'll just put it right here. We're going to talk about some common quadratic identities to address this problem here ultimately. So that size, that seems pretty good. And so over here, we're going to work through our common quadratic identities. So these are just some, this is what you want to memorize more than the quadratic equation, to be perfectly honest. Because if you don't recognize the common quadratic identity in this, what the GMAT would quantify as a difficult problem that we've got over here, you're not going to know how to solve this problem within the 3-minute maximum, 2-minute average that the exam requires. So the first is going to be what the factor is of x squared plus 2xy plus y squared. So what does x squared plus 2xy plus y squared factor to? So what is x squared plus 2xy plus y squared? And you factor it, and it is exactly x plus y times x plus y, or what is usually simplified even further to x plus y squared. So our first of the common quadratic identities. Now the second is going to be x squared minus 2xy plus y squared. And that's going to be equal to what factored? So what is x squared minus 2xy? And faster than I can even type it out on the chat box, it is indeed x minus y times x minus y. And that, of course, is equal to x minus y, the quantity, squared. And the last of the common quadratic identities, and the one that's ultimately going to be relevant to this problem, is going to be x plus y times x minus y. And oops, I did it backwards. I gave it away. It's going to be because I did one side than the other. So it's x squared minus y squared, which factors down, even though I did a bad reveal here, to x plus y times x minus y. Sometimes the brain doesn't continue to go in the same direction every time. And the reason for this is that we see that the middle terms cancel out. Because here we know that xy plus minus xy is equal to 0. So that's how you know that you've got a common quadratic identity. Any questions about common quadratic identities? So let's go back. There we are. So let's take a look at this n equals 3 to the 8th minus 2 to the 8th. And so basically there. So how can we rewrite the equation for n using a common quadratic identity here? So let me ask it a different way. Which of the common quadratic identities might be relevant for, yep, it's the difference of squares, and that's what this is technically known as here. The difference of squares. So how can we factor following, excuse me, the difference of squares? So how can we factor 3 to the 8th minus 2 to the 8th following the difference of squares? Because we basically have to square root it to a degree in order to get to a point where x squared minus y squared is being factored down to x plus y times x minus y. So if we just follow our first term binomial rule, yep, and so we've already got it in the chat box. What we're looking at here, a little bit. So we know that we could write this as 3 to the 4th plus 2 to the 4th times 3, or sorry, yes, times 3 to the 4th minus 2 to the 4th. Because we're to process the factoring or process the distribution, we remember that you add the exponents if you were multiplying the bases. So 3 to the 4th times 3 to the 4th becomes 3 to the 8th, as it is desired to be. 2 to the 4th, 3 to the 4th times negative 2 to the 4th is just negative 2 to the 4th times 3 to the 4th. Then we've got positive 2 to the 4th times 3 to the 4th. Those two things will cancel out. And then we've got the minus 2 to the 8th. Now, can we process any further? The expression. Yes, we can. Yes, we can. And which side can be factored further? Difference of squares again, and that's going to be the 3 to the 4th minus 2 to the 4th. So that goes here, and we've got 3 squared plus 2 squared times 3 squared minus 2 squared. And so again, we've got a couple of different situations here where we can break it down based on the difference of 2 squares. Now, at this point, I probably know what some factors are of these things, since I know that these are basically all the factors of n. These are factors of n, all of this stuff up here. So 3 to the 4th plus 2 to the 4th, well, how can I rewrite 3 to the 4th as a common square? So 3 to the 4th, 3 to the 4th is equal to what squared? 9. Yep. So we're looking at 9 squared plus, and if we do the exact same idea, 4 squared. Also know that 9 squared minus 4 squared is also going to be a factor. And so if we just did the math here at this point, and there will be some math required on either, on the GMAT, you'll need to use your mental math acuity. On the GRE, you can just use a calculator. But here we've got 9 squared, which is 81. 81 plus 16 is going to be 97. 9 squared again, 81 minus 16 is going to be 65. And so we know that this is out, this is out. Point, since I know that 97 is going to be one of our factors and 65 is going to be one of our factors, I have to be able to figure out, I should be able to figure out that 35 is not coming out of either of those two numbers. But you'll also note that once we factored it down further over here on the right-hand side, that 3, whoops, go back to my nice little teal here, 3 squared plus 2 squared is going to be equal to 9 plus 4, which is 13, and then 3 squared minus 2 squared is going to be equal to 5. And of course, those are the other two choices, D and E. So what is not a factor of n? It's got to be choice C, and that's 35. Now, this is mainly going to be a discussion just to close out. Well, first, any questions about or the common quadratic identities that we talked about? Any questions? This example, excuse me, or the common quadratic entities. So the last thing we're going to talk about, and it is really more a theoretical that you might encounter on the GMAT. It's going to be exceedingly unlikely, but just because I know that anytime folks come into these sorts of lessons, even though they don't need it, we will at least talk about what the quadratic formula is. So the way that the quadratic formula is set up, so the quadratic formula and defined, again, really for informational purposes only. Because you should not find yourself needing to use this on the exams. If your formula, you are probably looking at a situation where you could have solved the problem in a more efficient, logical way. But we know that the quadratic formula, your x value is, and well, first we've got to set it up 4 formulas or functions in the ax squared plus bx plus c format. So we know is going to be equal to negative b plus or minus the square root, I need a bigger square root, of, there we go, of b squared minus 4 times ac all over 2a. And now you can see why we didn't want to apply this to that first problem that we looked at when we could just plug in values for a quantitative GRE. Now, the main thing here is to recognize what is known as the discriminant, because you're not going to want to solve using this equation. It's just going to take you too long, and it's not worth the time in 99 out of 100 cases. But what is known as the discriminant is the b squared minus 4ac part. And for these exams, it cannot, well, actually, rather than saying it cannot be negative, I'm just going to say that b squared minus 4ac squared must be greater than or equal to 0 on the GRE or the GMAT. Because otherwise, we're going to have to be taking the square root of a negative, and we're getting into imaginary numbers, and imaginary numbers are not the purview of the GRE or the GMAT. So you can use that discriminant to potentially identify non-real values, especially as it pertains to data sufficiencies. There aren't many kind of indicators about this, but it is something that can be useful, just knowing that I can test that part and that part alone, because I know that the square root of a negative is not possible. It's just not real. And only real numbers on the GRE and the GMAT. So any questions about quadratic formula and the discriminant? Again, this is something that doesn't really come up all that often. There weren't any available examples of it that I was able to pull either, and it was at least, you know, wouldn't require like 30 minutes worth of exposition. So I just wanted to talk about this very high level. So any questions about the quadratic formula and the discriminant, or anything else that we've covered today? We have reached the end of our quadratics overview here this morning. How common are quadratic inequalities? That's kind of what we just talked about, not very. On the GRE, so just had a question about quadratic inequalities. It is very, very unlikely to encounter a quadratic inequality on the GRE. Like, it would be on the hardest section, and it would be, with the exception of like maybe a plugin, right? And even if you're going to have it show up in the harder section, it's probably going to be what I like to call that engineer type of question, where they're hoping that you're going to spend way more time doing that problem than you should. Now, on the GMAT, it's only slightly more likely to appear on the GMAT, and usually in data sufficiencies. And that's the other reason I wanted to keep it just kind of high level here, because at least every concept that we talk about in the problems is applicable to both the GRE and the GMAT. You're not going to see a quadratic inequality problem show up on the GMAT, with the exception of potentially on some of the hardest data sufficiencies. And the data sufficiency, obviously, one of the is unique to the GMAT, so doesn't really have applicability for our GRE folks out there. But hopefully that answers the question about the quadratic inequalities. Which exam, for the person who's asking this, are you considering? GMAT, yeah. So if it's the GMAT, then that would be where you'd see it, is in potentially data sufficiencies. But there, that the discriminant thing that I just talked about can be helpful there, because if you know that discriminant rule, that will help you determine if I can find anything, because if I know that I've got a non-real formula, non-real function, then the discriminant kind of cuts that down to size. So that's, you've found like the one use case we're talking about GMAT data sufficiencies, because it's, I mean, I'm just going to ask the individual here, but have you found this type of problem in the problem solving? Because I'd be surprised if you found any sort of quadratic inequalities on the problem solving side of things, because it's just, they're not gonna, and again, depending on which third party materials you've been using, some of the third party stuff is actually harder and covers things that the actual exam doesn't. Yeah, it's not, yeah, there are some like really high end things that can show up once you pass a 750 range, but it's gonna be. But good question, very specific one. So I hope that in the GMAT webinar, yeah, yeah, I wouldn't worry about it. To be perfectly honest, especially the third-party stuff. They tend to get into some of those like weirder things. If you use that discriminant rule, that probably would work, not knowing exactly what problem you saw. That would probably work to help solve whatever you're looking at, or it's the common quadratic identities, because those will show up as well. Any other questions about quadratics today? This was intended to be an overview, right? So we started the very basics of just distributing and combining like terms, right? That's the very basics of working with a quadratic. Then we talked about factoring in order to solve. Those are the main things that you're going to need to know. We talked about how using that basic quantitative comparison from the GRE, that if you just plugged in here, and that problem would very certainly be applicable to, say, a data sufficiency format if they wanted to, for that y equals 2x squared plus 7x minus 3 thing. Or if you just plug in 0 and 1, you're like, I can tell it can go either way, so I don't really want to deal with that rather difficult quadratic factor. Then we saw the applications that are somewhat more unique of the quadratic concepts. And it really does, in many cases, come down to identifying that I've got to work with a quadratic. I may be solving for something unique like that 2L plus 2W, as opposed to just solving for an individual variable. Don't auto solve for individual variables on this exam, on either of these exams, just across the board as well, because you can't actually solve for L and W here if it's not possible. So you have to just solve for the perimeter. And then we saw that last one about the factor of n. You have to recognize identity. Quadratic are often ones that you either know or don't know. So consider them to be something that if you don't understand it on the exam, you may want to skip strategically. And the online GMAT exam, I'm not certain. The last I had read, it was available through, I believe, August 17. I have not heard if they have extended the online GMAT. I would just have to say, continue to check MBA.com for updates regarding GMAT availability, and ets.com/org for GRE availability. I can say that the GRE availability for their at-home exam has been extended through September 30 at last check that I made. So keep on looking at those resources. As we get news at MyGuru, we tend to try to put out blog or social media posts as well. So follow us on Facebook or Twitter and our blog for continued updates. And to everyone who came here today, I know some of you have seen before, welcome back. And to newcomers, thanks for joining. Again, we will have some updates on additional webinars and topics moving forward starting next month, probably by the end of the week. So if anybody has any questions, feel free to ask them in the chat box. Otherwise, have a great rest of your day wherever you are, everyone.